Good morning, students. In this lecture, we will discuss introduction of powder metallurgy. Before talking about the powder metallurgy, we want to discuss to you some history about powder metallurgy process. As you know, though, that archaeological evidence suggests that powder metallurgy originated in Persia around 2500 BC, while sociological evidence indicates that ancient African tribes may have had similar technology to produce the iron powder, which was then compaction bonded. The Incas in South Africa processed platinum over 400 years ago using powder metallurgy techniques. One of the first significant modern commercial uses of metal powder processing was manufacture in 1910 of tungsten filament for additions light bulb. Yani, metal powder also find a number of other application. For example, iron powder is used as a food additives in breakfast, and zinc is used in pharmaceutical companies, and aluminium as a paint pigments, and silver is a major ingredient in dental amalgam. So these are the examples of metal powder that used in many applications. And in the process of making a part by powder metallurgy, powder of metals or metal oxides are blended together, sometimes with addition of binders, fluxes, or lubricants. The final mixture is poured into a die and forced together by high pressure. The part may be heated while pressing or placed in a furnace afterward. Surface melting causes the grains of metal to allow and bond, producing a solid part. So, this is the basic physics behind the powder metallurgy process. The powder metallurgy has several advantages over normal alloying processes. Dissimilar metals that would normally segregate due to differences in density of melting point can be forced to alloy, and additional metals that do not bond can be cut into the matrix and influence and the bulk properties of the material. And varying the temperature or pressure during the fabrication can also affect material properties. Parts can be forged to final or almost final shape, eliminating costly machining. So, powder metallurgy is useful in making parts that have irregular curves or that are hard to machine. Though machinability is the property of any metal. That metal can easily machined, so machinability will be good. But some materials are so hard and they are not able to machine. So powder metallurgy is useful in this case. It is suitable for high volume production with very little wastage of the material. This is very important point in powder metallurgy process. You can recycle all the wastage material, and there is a no waste of material, no scrap piece generated during the machining process. For example, if you are doing any cutting operations, so definitely scrap pieces will be produced, and it is a wastage of material. But in case of powder metallurgy, you can overcome this disadvantage, that you can very little wastage of material. Secondly, machining is virtually eliminated, and powder metallurgy processing is a useful approach for producing a cutting tools, high performance, and aluminium composites for aerospace applications, and mechanically alloyed nickel based superalloys cannot be readily produced using any other technique. So powder processing is also useful for producing small lots of new materials, since existing commercial powders can often be blended together to produce the desired composition, avoiding the cost and facilities required for custom melting. And powder metallurgy is also capable of producing a wide range of product form, ranging from billets to preforms to near net shapes, shape of parts. And powder metallurgy is a fabrication technique and involves blending and compaction of powder material into desired shape and followed by ये हीट ट्रीटमेंट एंड सिंटरिंग. सिंटरिंग एक प्रोसेस होता है, ये जो हीट ट्रीटमेंट प्रोसेस होता है परफॉर्म किया जाता है पाउडर मेटलर्जी में, and to produce a component. And powder metallurgy is especially suitable for metals having high melting temperatures, and powder metallurgy parts can be mass produced to net shape or near the net shape, and eliminating reducing the need of subsequent machining. And you can there is a little wastage of material that I have told you, and 90% starting powders are converted into the products. Only 3% waste of the material, generally it will be recycled, so this is not a big loss. And earliest use of iron powder dates back 3000 BC to and 2500 BC, and Egyptians use it for making the tools. जो इजिप्ट के लोग थे वो उसको पाउडर मेटलर्जी का यूज करते थे, वो टूल्स बनाने में यूज करते थे. तो दिस इज द बेसिक history of the powder metallurgy, and I have introduced you about you powder metallurgy. Modern era of powder metallurgy begin when W lamp filament were developed by addition. Yeah, that I told you कि एडिशन बल्ब का जब इन्वेंटेड किया तो उसका जो फिलामेंट था, definitely that is made by the powder metallurgy process. So this is a big advancement in this process, and component can be made from pure metals, alloy or mixture, or metallic and non-metallic powders. And commonly used material are iron is used, that have already told you that. अगर हम हिस्ट्री की भी बात करें तो पुराने टाइम से आयरन पाउडर यूज होता है, कॉपर यूज होता है, एल्यूमिनियम यूज होता है, निकेल इज ऑल्सो यूज फॉर मेकिंग द powder for powder metallurgy, and titanium, brass, and bronze, steels, refractory metals, those have the high temperature property, can absorb the high temperature. For example, if you are going to make a furnace, that you have to use the refractory material. For example, clay, चिकनी मिट्टी होती है हमारी, ईंट होती हैं. These are the examples of the refractory material because it has the property to absorb the high temperature. So use wisely for the manufacturing gears, cams, and gear. You know very well what is the function of the gears. It is used to supply the powers, yeah, transmission of the powers, and one end to another end. And cam followers is used. If we are talking about IC engine, then the application of input and output valves opening and closing with the help of the caps and the flowers, and bushings, cutting tools, and piston rings, and connecting rods, implants, etc. These all the products has been made by powder metallurgy process. Powder metallurgy is a highly these are the some examples of uh, products that has been made by powder metallurgy process. You can see easily in this diagram. And powder metallurgy is a highly developed method of manufacturing reliable ferrous and non-ferrous parts. Powder metals use are brass, bronze, stainless steel, and iron, that I have already told. If we are going to talk about the basic step of powder metallurgy, then raw materials prepare करना and mixing करना. Raw materials elemental or alloy metal powders, additives, if you want additives, graphites, dye, lubricant, these are the some additives that will be mixed in the powder. And after that the mixing process will be done, and then forming process, hot compaction and cold compaction. compaction में हमारा क्या होता है, materials जो होता है हमारा पाउडर, उसके particles को हम फ्लो में या छोटे छोटे पार्टिकल्स में ब्रेक करते हैं. आफ्टर दैट सिंटरिंग हैज बीन परफॉर्म, एंड दैट ऑप्शनल मैन्युफैक्चरिंग स्टेप्स आर here: repressing, coining, sizing, resintering, forging, re-rolling, and metal inflation. These are the optional manufacturing steps. ऑप्शनल मैन्युफैक्चरिंग स्टेप्स के बाद ऑप्शनल फिनिशिंग स्टेप्स होते हैं. फॉर एग्जांपल मशीनिंग हो गया हमारा, हीट ट्रीटिंग होता है, स्टीम ट्रीटिंग होता है, प्लास्टिंग इम्प्रीगनेशन होता है, प्लेटिंग होता है, ट्यूबलिंग होता है, ऑयल इम्प्रीगनेशन होता है, शॉर्ट पिनिंग होता है. एंड आफ्टर दैट फिनिश्ड प्रोडक्ट, जो प्रोडक्ट हमें चाहिए, डिजायर्ड प्रोडक्ट हमारे सामने आ जाता है. If Now I will talk about main characteristics of the powder. That powder you are going to use in powder metallurgy. So what is the basic characteristics of powder? For example, morphology. Morphology is a basic main characteristics of the powder that you have used for making the products with the help of powder metallurgy process. Morphology of powders can be critical in determining both flow characteristics as well as playing an important role in the heat and momentum transfer to the powder during the spraying. Generally, the morphology of the powders can be described as irregular and blocky or spherical. Irregular powders are characterized by the presence of wide range of the shapes. If the regular particles are mixed, they have the identical shapes, and from cubic like structures through to needles, and blocky powders tend to have shapes where the largest and smallest dimension of powders particles are quite close. Spherical powders are broadly spherical in shape. And another basic property of the powder are the powder size, range, and distribution. In general, powder are designed in terms of simple size range, and historically, these are often quoted in journal powders are designed in terms of a simple size range, and the mass numbers actually define the number of wires used per inch in standard, and the symbols plus and negative minus are also used to denote respectively powder which is either retained by or passes through a particular sieve. So while sieves may still be used for classification of powder, measurements of size is frequently carried out by instruments using laser light scattering. These plot the size of the powder particles in terms of an equivalent diameter of projected sphere. For a spherical powder, this quite accurate but irregular shape. So the size given will always be larger than the actual size. Now, the particle size distribution is important to end user in the following ways: direct impact और फिनिश प्रोडक्ट क्वालिटी. अब पाउडर का जो साइज होता है वो डेफिनेटली प्रोडक्ट की क्वालिटी पर इम्पैक्ट करता है. जो आपने प्रोडक्ट बनाया है पाउडर मेटलर्जी प्रोसेस से, उसके अगर जो पाउडर पार्टिकल्स यूज हुए किए हैं उनके पार्टिकल्स की रेगुलर शेप से डेफिनेटली इट विल बी इम्पैक्ट ऑन द पाउडर प्रोडक्ट क्वालिटी एंड ईज ऑफ इफिशियंसी ऑफ द फिलिंग ए डाई. कितनी आसानी से डाई के अंदर पाउडर फिल किया जा सकता है, that is depend upon the size of the particles of the powder. Is that clear? And wide size distribution allow voids between larger particles to be filled with small particles. And porosity, fine particle porosity is a defect that will be occur due to the air and environment contamination and entrapment in during the operation during the process. अगर एनवायरनमेंट में मौजूद कंटामिनेशन, धूल मिट्टी के कण या गैसेस जो है हमारे प्रोसेस के टाइम पे मटेरियल के अंदर मिक्स हो जाती हैं जाके, तो डेफिनेटली इट विल बी मेक पोरोसिटी. ये खाली जगह बना लेती हैं जिसको पोरोसिटी बोलते हैं. एन एक्सिस ऑफ फाइंस has negative effects on flow properties and environment contamination that I told you, and balancing the property needs to dynamic process controls. And another basic characteristics of the powder is powder flowability. The flowability of powder is very important in all thermal spray processes. Poor flow leads at the very least to in the powder feed rate and the coating buildup rates, and generally Hall flow is used to characterize powder, and the Hall flow is measured by timing the flow and of a sample of a powder through the standard orifice. Hall flow is affected by the both powder morphology and size range. So generally the more irregular shaped and the finer the powder ross is in the flow. कैसे powder flow हो सकता है if you are doing any and spraying process? तो डिपेंड करता है कि मॉर्फोलॉजी प्रॉपर्टी कैसी है और जो हमारा पाउडर है पाउडर के पार्टिकल्स के साइज क्या है, इसके ऊपर भी पाउडर की फ्लोबिलिटी डिपेंड करती है, कितनी आसानी से वो फ्लो हो सकता है. And another one is the chemical composition. Obviously, although the general chemical specifications can be set, there can be wide variations in chemistry from lot to lot of powder, and these variations can be often be blended out by mixing different lots together. However, there can also be problems in that while the average chemistry is correct, for example less than 0.05% iron, this impurity can be formed by clumps of iron particles present due to the mechanical treatment during the sizing process. So this is the basic chemical compositions. And sprayability, regardless of how and what is specified in the resultant powder products. The sprayability of product powder is often the only sure way of the ensuring the product is consistent. And another is the production of metal powder. How to produce this powder for making a product through the powder metallurgy process. So this is the basic thing that you have to know, that how can you produce this powder. So I will tell you some name of some cheapest raw material used in the production of the powder metallurgy components are the metal powders, and several techniques have been developed which permit large production rate of powdered particles, often with considerable control over the size ranges of the final grain population. These consist of fine, high purity metal powder produced by processes such as automation, mechanical communication, chemical reduction, electrolysis techniques, and aggregations. These are the basic mechanical process that is used to produce the powder, that is used to make the powder metallurgy products. We will discuss this topic in our next lecture. And now, thank you. If you have any question, you can ask what is the powder metallurgy. That I have told my previous lecture, it is an art and it is a forming process. You can produce the use the metal powder to produce the any type of the product. There is a little wastage of the material, and it help to shave the cost, and it help to recycle the material. So this is the basic goodness of this product. So thank you and very much. If you have any question, you can ask.